Okay, hello everyone. Today we're going to be talking about polyethene, polypropene, and polytetrafluoroethene. This one is also known as teflon. Okay, let's get into polyethene and explain the structures around that. Okay, so polyethene or polyethylene can exist in two states. Here we have low density polyethylene and high density polyethylene. Okay, they're both formed via that addition reaction that we looked at before with ethene and then forming that long chain of ethene molecules. Okay, but when they form that long chain, depending on the conditions that they're reacted with, they'll either form low density polyethylene or high density polyethylene. Okay, so polyethylene and polyethene are the same thing. You'll see it written both ways in your exam as well. So some characteristics of low density polyethylene. It is a highly branched structure. Okay, so low density polyethylene. Okay, and because it's highly branched, it's actually going to be more flexible and have a lower melting point. And on the contrary, high density polyethylene, that is little branching, so it's more linear. So it's okay, and because of that, it's actually going to have a higher melting point because those polyethylene chains are stacked closer together and there's less branching, so there's actually going to be stronger intermolecular forces within high density polyethylene compared to low density polyethylene. Okay, so it's actually going to have a higher melting point, and it's also going to be less flexible because they're stacked so tightly on top of each other and there's not much room for them to kind of move around. Okay, so this is kind of a summary of the two different types of polyethylene that you'll see. So low density polyethylene, more branched, there's more room between the chains. You think of it like that, so there's more room for them to move, so it's more flexible, and therefore they have a lower melting point as well. Alright, so generally these have weaker intermolecular forces. Okay, high density polyethylene, that is less flexible and has a higher melting point because they're stacked on top of each other. Alright, and there's less room for those straight chain molecules to move around. Okay, alright, so that's the main difference for polyethylene. Now let's have a look at polypropene. Okay, let's have a look at this diagram here that I've drawn. So this one we're talking about polypropene, and it exists in three main different forms. So polypropene is formed just like polyethylene during an addition reaction, but because it's polypropene, we'll also have a CH3 group attached on one side of that double bond. So because of that, during the addition reaction, that CH3 group will either be on one side or it can be on another side, like this here. Okay, depending on that arrangement of the CH3 group, that determines what type of polypropene it will be. So we have isotactic, syndiotactic, and atactic polypropene. Let's go into a little bit about what each type actually is. So isotactic polypropene, that's when all the CH3 groups are on the same side of the carbon chain. So just have a look at this one here. We've got one, two, so the CH3 group on that second carbon there, and then the CH3 group on that last carbon is also on the same side there. So all the CH3 is on the same side. That makes it isotactic. And because of that, some properties of isotactic polypropene is it's crystalline, strong, and has a high melting point. Okay, so there's some physical properties of isotactic polypropene. And if we go down and we look at syndiotactic, that's when the CH3 groups alternate sides. So you can see here, CH3 group is here on the second carbon, and on the fourth carbon, it's down here. So you can see it goes from the top side to the bottom, alright, and that properties of syndiotactic polypropene is it's crystalline and it's slightly more flexible than isotactic polypropene. Alright, and now let's look at atactic. So atactic is kind of the random arrangement of the CH3 groups. Okay, in order for me to draw that, I would have to draw a very long carbon chain. So I'm not actually going to draw that, but you can imagine that you'd have some that are on the same side and you have some that are on different sides with no real pattern. Okay, so that's what atactic polypropene looks like. And some properties of that is it's a soft and rubbery compound, right? So whereas these two were fairly strong and crystalline, atactic is more soft and rubbery material. So it's kind of gone from most strong to most flexible down the bottom here. Alright, so that's pretty much all the different forms of polypropene that you'll come across. If you understand these different types and how to identify them and what features make them that type, like isotactic, same side, syndio, different sides, and atactic is just random. Alright, cool. Now let's have a look at Teflon. Okay, so this here is Teflon, or polytetrafluoroethene. It's used a lot for non-stick pans due to its chemical formula here. So we've got carbon and fluorine, and that bond between them is actually really strong. So it's a very stable molecule, and that means it doesn't react very well with other molecules. So because of that, it lines the non-stick pans because it doesn't stick to anything in the pan because it doesn't react. All right, and this is how you draw the repeating unit for any polymer. So this is just Teflon. So we've got 4 fluorines on each carbon. So there's actually no hydrogens on polytetrafluoroethene. The hydrogens have instead been replaced with fluorines. Okay. If it was ethene, if you're drawing polyethene, then you would have hydrogens here instead of fluorines. Now these square brackets on the outside, that just indicates that it's repeating across multiple units. So we'll have this on this side and this also on this side, and just keep going for n amount of times. All right. We did cover this a little bit more in the addition reactions video as well, but this is kind of giving you an idea of how it's very similar to the structural diagram for polyethene. Only difference is those hydrogens have been switched out for fluorines. Okay, so we have a very low friction for Teflon, and it doesn't react well, so it's chemically inert to other species as well. Okay, so that's pretty much everything. One more thing with Teflon, it also has a very high melting point. Okay, so it has a high melting point because of those strong bonds. High melting point. Okay, it's also resistant to heat and corrosion as well. They're the key things to know about Teflon. Alright, that's pretty much everything for this video. If you have any questions, let me know. Thanks for watching.